So here we are. We're wanting to construct a set that consists of, and I copied this wrong, that needs to be the intersection, that consists of the intersection between these two sets. So what I'm going to do is I'm going to just write out what both of those sets look like. One of the sets is from -3 to infinity, and it had a bracket with it. Do you remember what the bracket meant? Included. So, it's the portion that's included. Now, the other part of the set is what goes from -infinity all the way up to +1. And that set would look like this. So we want to know what the intersection of those two sets would be. What happens if I take this number line and put it exactly on top of this number line? Well, what's the shared region? The shared region would be what we have there, which would be, on a number line, it would be from -3 to 1. Or, if you wanted to put it in set notation, it'd be the set from -3 to 1. Now, technically in set notation, you would write x such that x is an element of, but they're not interested in that. All they're wanting to see is this portion here. So it is that intersection set there. Now, the rest of what we're looking at here is just inequalities. The first inequality I want us to see is a compound inequality. And a compound inequality is an inequality problem that has multiple inequality values in it. So I'm going to go with 5 is less than or equal to 3x minus 4, which is less than 18. Now, there are a couple of different ways to do this problem. I like working these problems as two separate inequality problems. So I'm going to split this into 5 is less than or equal to 3x minus 4, or 3x minus 4 is less than 18. Because that's what it's saying. Basically, this is saying 3x minus 4 is in between 5 and 18. So I want to see where it's greater than -5, but it's less than 18. Okay, now just solve these out like regular inequalities. Add 4 to both sides, I get 9, so 9 is less than 3x. Less than or equal to, I should say. So, divide by 3, 3 is less than or equal to x. Now, we don't typically, when we write inequalities out or speak inequalities, we don't tend to say 3 is less than or equal to x. We like saying x is greater than or equal to 3. It's just easier for us to see. This is not a required step, but I think it's going to help you out if you rewrite this as x is greater than or equal to 3, like that. Again, that's not a required step, but I think it will help you out. Likewise over here, I'm going to add 4 to both sides just like I did here. So your 22 plus 4 is, your 18 plus 4 is your 22. Divide both sides out by 3. So we get 22 over 3. And you could put that in your calculator. It's going to give you a decimal answer. This is an exact answer. There's no repeating sign or anything like that. So we want to know where is x greater than 3 but less than 22 over 3. So where it's greater than or equal to 3, I'm going to put here. Now, what 22 over 3 is between what two integers?
7 and 8.
7 and 8. Very good. 21 thirds would be 7. 24 thirds would be 8. So 22 thirds is right in there in between them. And that is the region I'm going to shade in. In other words, what this is saying is I can plug in any number between 3 and 22 thirds, including 3 but not including 22 thirds, and I would get a correct statement here. So let's plug in 5. What's 3 times 5?
15.
15 minus 4. 11 is definitely between 5 and 18, isn't it? So that is what that is saying. Is there a question about that? Again, you don't have to. You could just keep it in line right here and just work it straight out as a single problem. Just be careful if you do that. I prefer to split it into 2, but that is totally up to you. Now the next problem is absolute value inequality. In an absolute value inequality problem, we're going to work a lot like we would work a compound inequality problem. So I've got negative 16 is greater than negative 2 times the absolute value of 4x minus 5. Well, there's a little bit of a difference in an absolute value problem and a regular problem, regular equation. An absolute value equation, I need to isolate the absolute value. In a regular equation, I'm just looking to isolate the variable. But my first thing here is I want to isolate the absolute value. So what step would I need to take here to isolate the absolute value of 4x minus 5? Divide both sides by negative 2. Of course, in an inequality, if you divide by a negative, what do? Switch the signs. So I get 8 is less than the absolute value of 4x minus 5.
You divided by 2?
I divided by negative 2.
Yeah, that's right.
All right. Now, I also, just like in regular equations, I like for my absolute value to be in the front. It just helps me with aligning things. So if 8 is less than the absolute value of x minus 5, then the absolute value of 4x minus 5 would be greater than 8. Now, the next thing I want to do here, I mentioned earlier, I'm going to turn this into a compound inequality. So what I do to turn this into a compound inequality is I move the 8 to the front and make it negative. So it's negative 8. Keep this as a greater than. Then it's 4x minus 5. And then it's greater than 8. Again, slow motion what I do here. Negative 8, pull it to the front. Greater than 4x minus 5. 4x minus 5 is greater than 8. You're going to see that that's got some issues there, but we'll get to that in a second. All right, I'm going to split this into 2. Okay, is there a question about that? I took my compound inequality, split it into 2 separate inequalities. Okay. Add 5 to both sides. Negative 8 plus 5 is?
Negative 3.
All right, so I've got -3 is greater than 4x. So -3/4 is greater than x. So x is less than -3/4. Okay, here 4x is greater than 13. So x is greater than 13/4. So here's a situation where I've got them less than -3/4. And I'm greater than 13/4. So that is my solution set on a number line. How could I write that in interval notation? What's the farthest left this goes?
Negative. Infinity.
Okay, -infinity, and then where does it? To -3/4, and then it jumps, right? So it's 13/4 to infinity. Now, I'm gonna union those. There's not an intersection there, it's a union. Now, a side note here. I'm gonna go ahead and stop the recording.